Okay, so yesterday we talked about y equals mx plus b. So just to recap again, what did that look like? Okay, so here's what we were doing yesterday. Y equals mx plus b. The m was the slope, the b was the y-intercept. Specifically with the slope, we wanted to talk about rise over run. So we were concerned about making sure slope was always a fraction. So in this case, when it didn't look like a fraction, we could put it over 1, and then that is a fraction then. Okay, so moving on today, why is it looking a little bit different? Okay, so I need my equation to look like this. That is the goal. Y equals mx plus b. This equation does not. Okay? So today we're going to throw algebra into the mix as well. Okay, so we need to get y alone. That's the goal. So here we go. To get y alone, I'm going to get rid of the x stuff on this side. So to get rid of x, I'm going to subtract x. So 2y equals. Now, I'm kind of following this format. I like my x stuff and then my number stuff. So what kind of x do I have over here? Now I have a negative x plus 12. So I moved the x to the other side. Okay, then algebra, how do I get y alone now? I need to divide by 2. Okay, and again, I reminded you, algebra is like giving candy to kids. If you give candy to one kid, you have to give candy to all the kids or somebody's mad. So it would look like this. Y equals, does anybody know how I could write the fraction in front of the x? What is this all about? What would I write as a fraction number? Do you think negative a half? Would that make sense with that vision? Negative over 2, so negative a half, and then plus 6. So now, look at that. It matches this nicely. So I can see my parts. So the slope is negative 1 over 2. So that means I'm going to have to move down 1, and I'm going to have to go right 2. It means if a slope is negative, remember your line is instantly going to look like that, sliding down a hill. And the y-coordinate, the y-intercept, is 0, 6. So if there was no x, 0x, there would be a 6. Okay, so we graph. So we say, let's start at the y-intercept. So there's 0, 6. And then you make your move. Down 1, right 2. Down 1, right 2. And that's it. That's all I need. I need 2 points to show me that that's your line. Okay, then I had a little bit of a note here. I said, well, why don't we check our answer? So check your answer with the intercept method. So we've learned the intercept method, which is finding your x-intercept and your y-intercept. That's the intercept method. Okay, so we're going to divide this. If x was 0, if y was 0, that's the intercept method. Okay, so I'm going to cover up the x. If x was 0, I would have 2y equals 12. So the y-intercept is 6. If y is 0, guess what I'm going to do? I'm just going to cover this up. If y is 0, it's out. So if it's 0, I would get x equals 12. So would that look like it's the same thing going on? 6 here, and if I kept going, does it look like it would be over here at 12? Would that make sense? It fits all together, right? So you can see how I'm doing two different methods. It's going to make the same line. Okay, let's do one more. Okay, so give me some algebra here. I need y alone. So step 1, remove the x stuff, because you want y alone, so get rid of the x. So I would be subtracting a 3x to get it out. So it can be out of there. So 5y equals. I'm going to follow the order, so I'm going to write negative 3x and then plus 15. So I'm trying to line it up, the y, the x, and then the number. I'm trying to just line it up like that. So here I would divide by 5 algebraically. But again, if you do it to 1, you have to do it to all. Y equals, the fraction is negative 3/5 x plus, and then 15 divided by 5 is 3. So I got a slope of negative 3/5. So when I move, I would be going down 3, and then I would be going 5 to the right. That's my move. And then we discovered the y-intercept. So at the end here, 3. So the coordinate would be technically 0, 3, because it's a y-intercept. Okay, so you start with a y-intercept point, because that is a point, so you can put it on. Okay, so putting your pen there, you should go down 3, right 5. And there's my line. Okay, let's just double check using the intercept method here. Okay, ready? I'm going to take turns covering stuff up. So if I don't have any x's, what would y need to be? 5 times 3. Does that make sense? Boom, that is on our graph. We did it. Makes sense on our vision? Okay, now I'm going to cover up the y stuff. So if there's no y's, 3x equals 15. So therefore x would have to be at 5. And you know what? That's actually also on my graph already. So it worked the same. Okay, can I ask you what's on the back of your whole booklet of notes? Is it blank or is there stuff on it? It's blank. Okay, flip to that. I don't know if I have this anywhere in your notes. but I want to talk about special lines. Okay, so you can see how every time we've been doing stuff right now, there's been y's and x's both involved in an equation. What if I have an equation? I'm going to give you two examples here. What if there's an equation that you see with just one letter in it? They're special. So this is an equation that would just have an x in it, and this equation just has a y in it. So they're going to do something a little bit different. Okay, here's what I want you to do. Draw me any coordinate with an x value of 4. What would it look like if you drew me anything? There's a bunch of different things you could do, but give me any coordinate that has an x value of 4. So I drew the coordinate 4, 0. You could have drawn something else, so that's fine. Okay, draw me any other coordinate that has an x value of 4. Any other coordinate. I need a second coordinate that has an x value of 4. You could draw me there, you could draw me there, you could draw me there. Doesn't matter where you're drawing it. What's going to happen with our line? It's going to be a line that is exactly vertical. So if you forget the rule that it's vertical, just think, draw a point with a 4x. Okay, so the same thing, you can maybe predict what would happen with a y only. Draw me a coordinate anywhere that has a height of 4. So you can draw me any coordinate, you just have to have a y value of 4 on it. Okay, same idea, draw me any other point that has a height of 4. It could be anything. There, 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 there. Those points all have heights of 4. So what kind of line would it connect? It would be perfectly horizontal. Okay? Those come into play. They still come into play in grade 11 and grade 12, so those are just special and you just can't forget what they look like. Okay, and that's it for today.